Uh, I am Mansour Karam. I'm the global VP for data center here at Juniper. And I know it's a bit early, but I hope you're as excited as I am. I mean, that's just been a feeling of excitement these days that is happening pretty much every day. There is always new stuff happening every day. When was the last time we had 30,000 people cheer for a new ASIC? I mean, the last time I remember was with x86, possibly like the x86, and then we had 286, we were excited, and 386, and then when Pentium came out. I know I'm aging myself, but that's the feeling I'm getting here. It feels like that same level of excitement. And indeed, every morning you wake up, there is something new and exciting that you can use. Like I've installed GPT-4o on my phone, and I've become kind of dependent on it. I ask it questions every day, and I didn't know that thing existed just a couple of months ago. I went to LinkedIn to look at my blog that I written back in January. I'm sure all of you guys read my blog in preparation for this. And, that was the blog I wrote when we launched our AI native platform. And what I saw was like this little square on the side. And that was LinkedIn kind of nicely summarizing the blog for me. And I read it, and it felt like I couldn't have written it any different or any better. Even like highlighting the fact that were the first to launch an 800 gig platform. It was right there, written by AI. I mean, it's just one of those things where every day there is something exciting, and it feels like we should be all surprised. Like we are surprised, but at the same time we shouldn't be. I mean, that's just been that kind of incredible cycle of innovation that we've had since we've had Moore's law 50 years ago, or 60 years, I can't count, ago to the day, where Moore predicted that we would be doubling compute power every 2 years. In fact, what happened is that we kind of doubled every 18 months. And what it means is incredible innovations with once in a while amazing, crazy breakthroughs. And I was very grateful that since I came to the US back in 1995, and that was in September of 1995, which was actually the same month Netscape went IPO, I've been witnessing some of these inflection points, some of these great cycles of innovation, starting with, of course, the internet, every company trying to go online. That was the web revolution. And then the cloud revolution, when these services became a lot more sophisticated. And then the mobile revolution, we always remember Steve Jobs holding the iPhone, introducing the iPhone. It became clear at that point that everything we do, we can do it just from our phone. And then after that, we had the digital transformation. It was accelerated by the pandemic, where we realized not only can we do everything from our phone, but now we can do it from the comfort of our own homes, and all the way to today, where we're seeing this massive, great AI revolution. And so, and bringing it back to networking, look at the evolution of Ethernet during this period. When I was at Stanford in '95, 100 meg was kind of like the screaming, latest, exciting state of the art. And then 1 gig kind of fueled the web revolution, and then 10 gig fueled the cloud revolution. And then after that, we had 40 gig, 100 gig. Just if I remember, it was a year or two ago, we were sitting with analysts saying, 400 gig is arriving, but are there use cases for 400 gig? Maybe it's going to take longer for adoption of 400 gig. And then we get AI. We skip 400 gig, we go all the way to 800 gig that's shipping today, and we're talking about 1.6 and 3.2 terabit per second. And so if you're like me at the intersection of networking and AI, or like Juniper, I mean, of course, Juniper was founded in '97 as part of the web revolution. We've been experts at networking for many, many years. And then since the acquisition of Mist and Apstra, Juniper realized the importance of AI, I would say, very early, and we all became AI expert. So if you're at the intersection of networking and AI, it's an exciting place to be, because really AI, at the core of it, the engine driving AI is the data center, and the core of that data center is the network. The network is kind of the neural network in connecting all of the components that make up these AI clusters. But not only that, AI is also transforming the way we operate these networks. And so, again, if you're at the intersection of networking and AI, it's a really exciting place to be. And it's in the right time to kind of revolutionize networking and lead the AI networking wave. And hopefully what you'll see today is a lot of examples of how we're doing that. And in fact, back to that blog, that's when we launched our AI native platform, which was kind of like one big step in this direction. And so this AI native platform is quite ambitious, but at the end, it starts with being AI experts, really understanding, first of all, what data one has to collect. And at Juniper, we've been collecting data for many, many years, and we've become experts at knowing what specific data one has to collect. And then becoming experts at what models to feed the data into in order to provide the right insights and to our network operators, or to automate the network in the most powerful way. But it's also about building the right infrastructures to support AI workloads. So having the right secure infrastructure for AI. And I'd say it's all encompassing. We play in many domains, all the way from campus to data center, which is the focus today, to the WAN, and AI native spans across all the way from client to cloud. And I'm going to talk about these two pillars today: AI for networking and networking for AI. AI not for networking is how we're leveraging AI to transform how we operate networks. That's kind of like the first pillar. And the second pillar is networking for AI, which is what type of infrastructure, networking infrastructure, is needed to deliver on these AI use cases. And so let's start with AI for networking. For data center, in the context of data center for Juniper, the journey started with the acquisition of Apstra. And I was the co-founder of Apstra. We started Apstra back in 2014. We celebrated recently our 10-year anniversary, and we've been part of Juniper for more than 3 years now. And what Apstra set itself to do is to deliver this powerful automation of data center networks, end-to-end, the entire lifecycle, from designing to building to deploying and to operating data center networks. And we did it with this innovative approach that we invented called intent-based networking. We'll get a bit more into that, but before I describe the technology, what I want to say is that let me just tell you some of the outcomes we're seeing with our customers. Starting with, I would like to focus on reliability first. The reason we started Apstra is we wanted an automation tool, an automation solution that network operators could trust. Software that they could trust will run their networks with them with utmost reliability. Like in autopilot on a plane, you tell it to go to 10,000 feet, and then it will deterministically go to 10,000 feet. You know it's going to work. In fact, if you build your software right, you should get much better reliability, in order of magnitude more reliability than if you were doing things manually. And indeed, that is the outcome we're seeing with our customers. In order of magnitude improvement in reliability. That's number one. Number two, automation should let you run a lot faster, not just more reliably, but also a lot faster. And so we've seen deployment times, upgrade times, which have been accelerated tenfold. We've had customers upgrade their global networks worldwide across multiple vendors just by a click of a button within one morning. And then last but not least, we want to empower these network operators so they can do a lot more with less. We have network teams that maybe are just like a handful of folks running networks. So this is a bank that I'm thinking about in Europe, running a network that is supporting thousands and thousands of users. And these are stories that we see in and out. And so that is the type of outcome we see with our AI-based solutions, with Apstra, as part of our automating, as part of us automating data centers. 10x outcomes.
Mansour, you talked about experience first, or experience first, I think, was on one of the earlier graphics you showed, and then here you have operations first, which made me suddenly wonder if you mean operator experience first, or if you mean application user experience first.
It's a great question. In fact, when we say experience first, and this is kind of like a Juniper slogan, I would say, we're focusing on both. We're saying it is about the network operator. So it's the experience of the network operator. So we don't want a network operator to be spending way too much time and then doing things with the worry of and exposure to risk of making errors, right? So like we're improving the network operators' lives by giving them solutions that allow them to run very fast, but doing it very reliably. But also at the end, the network is there, to your point, to support the users and the apps. And we want the user experience and the users using those applications. We want their experience to also improve dramatically.
Yeah, I don't claim to have a huge audience, but anybody who listens to me for 10 seconds knows that I think that the functioning of the network and its management is fundamental, if not foundational, to the user experience.
Absolutely. I mean, the network touches every component, and we'll talk about that a bit more.
And it's so frequently ignored. I mean, by the lay person, let's say, or the lay tech person, it's taken for granted or not thought of.
I agree. It's one of those things. Networking is one of those things. You only remember your network when things go wrong, right? Otherwise, you're taking it for granted. This is why we say, the best thing for the network is that people don't know about it, because then it's working well, right? And so, I completely agree with you. The network is critical to making the user experience and the app experience be what it needs to be. Yeah, absolutely. And so back to Apstra, and just want to talk a bit more about intent-based networking and where we're taking this technology. The idea behind intent-based networking was that it's a layer of software. The way you interact with it is that you tell it what you want. Like, for example, I'd like to add a new rack, or I'd like to add a new virtual network, or I'd like to add a security policy. And then what the software does is that it makes it happen 100% reliably. It does it by configuring the devices, of course, but it's not just configuring the devices. It's collecting all of the telemetry, the state from your network, building a whole representation in the distributed data store that captures all of the relationships in a graph. And then by having all of this knowledge, it knows it can pre-validate whether a configuration change is going to deliver on the right outcome. And then it can test post-deployment whether or not a change that you've made indeed at the end delivered on your outcome. So it's a closed loop system. It's a closed loop system that is collecting telemetry and interacting with your network in real time.
Does it have a rollback to that then?
Thank you. It's because everything is described in software. Every time you make a change, we're able to keep a snapshot of the entire network. If you're familiar with Juniper rollback function, that's on a per device basis. This is a rollback function at the entire network level, the entire network. And not only can you roll back to where the network was prior to this change you just made, you can roll back to whichever version of your network you want. If you want to roll back to the way your network was Tuesday, a week ago, it's a click of a button.
So how backward compatible could you get? Like if you had an update, how do I put this? If you have an update that all of a sudden these backups just can't work because you have to roll back the software to make the backups work.
Yes.
Is there a plan for that, or
no? Well, so essentially, this is a great question. So what I'll say is, with Apstra, it used to be in the past, like say 20 years ago, that when you build automation, you're still manually interacting with your automation. It was like through the web or something. And of course, we have that with Apstra. You can do this. You have a web interface. It's easy to use, etc. But really, it's an API layer. Everything you do is through the APIs. And the type of thing you just described is orchestrated through the API. This is why I have here Terraform and ServiceNow. And what you're going to see through the demos today is how we've leveraged those technologies to essentially implement some of the workflows you're describing. And so you would have, let's say you're making a change because you want to upgrade your applications. So you could use something like ServiceNow, and you could orchestrate all of that. And then there is a component of that, which is the network that's going along with it. And let's say your network is upgraded and you're done with that upgrade, but the application team is not ready. And so even though everything was successful on the networking side, you have to roll back because your application guys haven't tracked with you. And that's all orchestrated through something like ServiceNow. And that's the importance of having this API layer. And that's also why what's really important here is that you want this API layer to be vendor agnostic. You want a loosely coupled architecture between your choices southbound and your choices northbound. And with Apstra, even though we're part of Juniper, we are still and we will continue to be a multi-vendor for exactly that reason. You don't want your choice of ServiceNow or Terraform in the northbound and all of the implementation you've done to be locked into the choice of the vendor that you've chosen southbound. Okay, and so part of that technology is giving you that loose decoupling that is so critical when you have an API layer, like you've described.
So, Mansour, two questions. You mentioned that you're talking to the solution almost in a natural language. Is that what you're using to say I want to deploy some portion of the network? Is that something that's
You predicted my next slide.
okay? I mean, a second question is are you simulating the network change before it's made, or are you checking the network change after it's made to see if it's still viable, or are you doing both?
I'm loving these questions. So we do both. You know how I said we have a distributed data store? In fact, I lied. We have two of them, right? So there is one which is for the staging of your changes, and we have one that is for your active network. Unless if you're not making any changes, they're exactly equal to each other. They're mirrors. But then when you start making changes, you're making changes in the staging area. And when you're making changes in the staging area, this is where all of the pre-validation happens. It's making sure that in the context of everything it knows and in the context of the intent you have, the changes you're proposing make sense. And it will not let you commit if it doesn't compute, if these things don't compute, if the pre-validation doesn't pass. And when the pre-validation passes, it will allow you to commit, and then you press commit. And hopefully today in the demos, you're going to see some of this. When you press commit, at which point the state from the staging distributed state goes into the active state, and which point the configuration are pushed, at which point the telemetry is collected, the tests are run on your real network to validate that indeed the network changed as you expect. The network change happened as you expected them. Yeah, great questions. And so,
and can I jump in there to finish that thought there? How much control does the operator see and have over each step in that process?
Oh,
we don't want
love it.
Our AI overlords just like rolling through here and taking over.
So when you're so at that same point, when you're about to commit, you have like a whole description to every last detail of every change that's occurring in your network. And you can go and review these yourself. In fact, we have customers that, they have like a step there where a human goes and, as part of the process, they review everything. And it's only when they review everything that they press commit, right? And then again, after you commit, you have an ability to roll back. When you roll back, you have an opportunity to say, okay, well, actually, I want to do this again, but I want to do this extra change. So you have tons of flexibility in how you do this.
And I could go in there and say, these changes, I'm confident in the system's ability to detect that it's correct, and I'm going to just, whatever it says is okay. These require an operator to say, yes, you can continue.
Yeah, I mean, at the end, it becomes very much based on the policies that you, as an organization, set up, right?
So we can let it go as fast as we want and stop it at the critical paces where we're worried about things going wrong.
Exactly. Like, for example, when I showed ServiceNow as one example, like we have some customers that use things like Slack, where there is also a communication that's going on with the various teams to Slack, and there is protocols in terms of like who has to approve, etc. That is going on as part of the workflow.
Right. And then in terms of change windows and things that we're required to maintain, those can be programmed into, so we make sure operators don't kick things off outside of legal change windows.
Yeah, so again, this is done through I would say these are done through the APIs. We have tons of role-based access control. So like we have different users, we have different that have very granular, we have a very, very granular control in terms of what they can access, right? These specific users. So you have super admins, you have admins, you have like the folks that are only doing design, and then you can be very granular in those authorizations. But then using the APIs, you can also restrict like access to the platform. Yep. But actually with change windows, one thing I'll say is there was one customer, just an anecdote, that had this change window on Saturday through the whole weekend, and they started deploying on Friday, and then they called me on Friday afternoon. I mean, clearly they were a bit, I would say, they were very excited and emotional, and they were like, Mansour, I just want to call you because I had reserved the whole weekend to do this, but then it's Friday noon, I'm done. I'm going home and spending the weekend with my family. So maybe, sometimes change windows are for the week. No, I'm kidding. It's a...
Well, seriously, you need to talk to our VPs. I love that.
You're talking about network DevOps. A lot of the methodologies around continuous delivery and continuous deployment in particular would say that there is no such thing as a change window. We will deploy changes, including network changes.
Yeah, no, I mean, I was joking. I would always recommend change windows, but I mean, in fact, with technology like this, you can do things a lot faster. The reason you have change windows is because you need to coordinate amongst multiple teams, right? So that's part of, so I'm not recommending no change windows. So I was going to just, I skipped the slide. So one of the things we're doing, well, as I mentioned, we are using intent-based networking to operate your network day in and day out, right? And so, like, this is the tool that you use to deterministically get outcomes from your network, make changes, like an autopilot on a train, on a plane, as I mentioned. But then in the process, you're collecting all of this data. And would it be nice if you took all this data and send it somewhere in the cloud in some AI ops layer that is not just collecting data from the data center, but also from your campus, from your WAN, from your SD-WAN. And this way you have like one repository for all of the state, like as I mentioned, collecting the right data and having the ability to then apply models on this data. And then this is where the chatbot can come in, and then you have an ability to, through a conversational interface, interact with your network. And also, this is, AI is probabilistic, and so these things are very complementary. Deterministically, you're making the right changes and operating the network, but then you can provide probabilistic insights in terms of, hey, I'm giving you visibility. I believe, like if you're having an issue, it's probably in that realm, right? So having that deterministic approach combined to that probabilistic AI approach is extremely powerful. And this is essentially part of what we launched in January, and we've delivered, and we started delivering in the first half of this year. Okay, and we haven't stopped there. The third aspect, and we delivered that in Q4 of last year, is application awareness. And the first step towards that is, I'd say, the most comprehensive flow telemetry available on any platform. But that's now part of Apstra, part of that same distributed data store. You can now collect a telemetry, application level telemetry, and combine it with network data, network state data. And this way, as a network operator, not only can you answer questions about whether or not your network is working well, but you can do that in the context of every specific app. In fact, that's really like what the job of the network operator. When the application team comes to them and say, hey, my application is not working well, you want to have the ability to tell them whether or not it's your fault, it's because of the network or not. Mean time to innocence.
Say it ain't so. It's never the network.
It's never the network.
It's DNS.
Or BGP, yeah.
So here, the summary, right, for AI for networking. We started with intent-based networking, deterministic control. We're adding AI-driven probabilistic insights, and then we're combining this with application awareness. And I dare any competitor to have a solution that's as comprehensive as ours with the outcomes that we are able to deliver to our customers. And one of the proof points, I'd say, is the number of customers that are upgrading to our premium licenses. We have standard, advanced, and premium licenses, and 68% of our customers in Q1 purchased premium licenses. To me, this tells me the amount of value, the value our customers are getting with our solutions. Okay, so that was AI for networking. So let's now talk about networking for AI. Essentially, the role, what networking infrastructure we need for AI workloads.
Well, before you move on, we did most of the talking in that first section about the deploy side. Do you have a similar story you could quickly share on the troubleshooting side of that implementations where this data actually raises issues in how the operators interact with that?
Yeah, no, absolutely. So, well, hopefully some of the demos will show you that. But we're collecting telemetry on a continuous basis, and you can, with Apstra, collect any telemetry that you want, that you can otherwise access. And so, once the telemetry is in this tool, you can run any analytics pipeline against this telemetry. It's completely custom. So, of course, we have a bunch of things that are turnkey in the solution, that are there out of the box, but then you can customize this to your heart's content. And so if there are any areas that, like for example, if for a given application you're seeing packet loss on a port, or you're interested in seeing if there is going to be any packet loss on a port, then you can get alarms and events for those specific occurrences. And so that goes a long way in helping you troubleshoot. So that's number one. And number two, we're now shipping all of the data into the cloud. And there, if we see any patterns that could indicate some sort of trouble kind of lurking in the future, like for example, for transceivers, we collect the state for these transceivers, and we know a signature of a transceiver that is about to fail. Right. So we don't wait for the transceiver to fail for you to go and to give you an alarm so that you go and replace the transceiver. We notify you prior to the transceiver failing, so that now you have an ability to go and replace your transceivers before they fail.
Okay, so that's all something I can select for automatically at the beginning, which ones of these alarms we're going to raise and push up to the NOC operations for escalation, and they're all pre-packaged based on your look at the data from other sources.
Correct. Yes.
And just to be clear, Apstra supports Arista, Cisco, Dell, any of these other solutions as well? You can
yes, absolutely.
Deploy, manage,
we have
troubleshoot.
Absolutely, and we have many customers that use them across these different vendors. Yes.
And is it just limited to that list, or kind of anything you can key on with an API? Or
so we have a whole. If you just actually probably if you ask GPT-4o, it will tell you. Well, it's all documented publicly, and there is a validated list of and qualified list of devices, which operating systems, etc. We're very detailed in specifying which platforms we support. Yeah.
So how far you can go in like orchestrating these different vendors and connect them together? So I'm talking, for instance, like VXLAN GPO. Stuff like that, where I will be able to like connect like different vendors together. Yep. Are you able to build like multi-site, multi-data center sort of a fabric, multiple different vendors?
So I'm a networking guy. I've been in networking my entire career, and wasn't that the promise of networking, that you should have that ability to connect these devices?
Back here in the real world.
Isn't that why we've spent so much time on standards like BGP and EVPN, VXLAN? And this is why I feel so strongly about this vendor agnostic thing, right? Like, why would you throw all of that away by bringing in a management solution that only works with one vendor and locks you in completely? We might have as well like implemented completely proprietary version of BGP. Why do we need BGP if you're going to do that, right? I mean, so absolutely, you can do that to the extent that the standards allow it, right? So, we've seen, for example, a VPN VXLAN is a good example. Everyone strayed, and kind of it wasn't really consistent. I think we're seeing a bit more consistency, but like to me, we're limited by the ability for the standards to allow for that, right? So that's essentially the limiting factor. But if the standards allow it, then there is nothing in the solution that will prevent you.
Okay. So let's say like, I'm a client and I'm acquiring like, companies, and my data center is now Cisco. I'm going to acquire another company. They are doing Arista, and I'm going to onboard Arista into Apstra. can I then like literally use the Apstra to sort of like connect these two data?
Well, you're describing exactly, like the use case that one of our customers has used Apstra for. Yep.
And Apstra runs in the cloud or runs on-prem?
No. So Apstra runs on-prem, and there is a really good reason for that. By the way, this session is running longer than we originally anticipated, but I'm really excited about it because of all of the questions that I'm getting, and I would like to encourage them. So this is good. But what I'll say is with sorry, repeat me the question.
Does it run in the cloud, run on-prem?
So
both?
there is a reason why we run Apstra on-prem. The reason is we need to hit the highest levels of reliability. Remember, reliability is the number one goal. We require an out-of-band network for that reason. You want to be as close to the network as you are. The last thing you want is you're trying to make a change and you can't access your network, right? Having said that, the AI ops layer I described is in the cloud because that's more about providing you insights. That's more optional, right? If you lose access to that, that's not going to affect your network. Okay, so that's the answer. Okay, so let's talk about networking for AI. Let me motivate this by, so we talked about the role of networking and how it's so critical for users and applications. Well, in the context of AI clusters, that is even more the case. The network is critical in AI clusters. If you think of an AI cluster, it's a really complex machine. It's made of like all these different components, different layers of memory, SRAM, DRAM, flash, attached storage, different kinds of compute. You have CPUs, you have GPUs, you have accelerated compute, different types of networks. You have the front end, the back end, the storage. And in fact, in one of the sessions, Praful is going to dig into the details of that. You have the scale up, the scale out network. You have all of these components, and they all have to work in this harmonious, balanced way if you want to deliver on an optimal job completion time. Job completion time is the measure, the critical measure where these clusters are measured. It's how long it takes you to train a model, right? And if you're familiar with some of these models, they sometimes take months to train. But you know what? If your GPUs are underutilized or like your model is, your AI cluster is out of balance, then you can add many, many more months to that. And these GPUs that you've spent like $35,000 to $50,000 for each of these, they are going to run completely underutilized, which would be sad, right? And so the network is critical to making sure that you get optimal performance to kind of reduce your job completion time to a minimum. It's kind of like the system of highways and streets. Like if there is congestion there, if you're not load balancing your traffic the right way, if you're having accidents, I mean, that's my analogy for packet loss, right? Then essentially you're dead in the water. But then you may ask, well, that's true. Like the network is really critical, but like, what does it have to do with Juniper? Aren't these networks specialized? Isn't it like something like InfiniBand that is running in these clusters? And to me, it's actually déjà vu in so many ways because being in networking for a long time, we've had these battles. This is not the first time we see this, right? I remember back in 2008. Whether it was oil and gas or high frequency trading, there was InfiniBand came in, but at the end, the saying, never bet against the US. I think in networking, the equivalent would be never bet against Ethernet, right? Even McAfee had to go and eat his word, literally, because he expected the collapse of Ethernet, which never happened. He's, by the way, one of the co-inventors of Ethernet. And the reason is pretty clear. I mean, Ethernet is the most wide deployed technology where you have most of the investments. It has the widest ecosystem. As I mentioned, it's really critical to get these AI clusters working well, and critical to that is visibility, debuggability. You have hundreds of management tools with Ethernet. You can go and tap on the link, and you will know exactly what's going on that link. This frame format is understood for decades and decades. You also have a massive ecosystem. It works with any GPU. I know NVIDIA today has the lion's share of the market, but for specific use cases, you may get much better performance with other GPUs, and we've seen customers deploy, kind of many different options, including AMD, Intel, and newcomers like Cerebras, where for some use cases you get, orders of magnitude difference in performance. And InfiniBand only works with NVIDIA, whereas Ethernet is going to work across the board. And last but not least, because again, it's ubiquitous technology and there is so many investment at the end, the price plummets much faster. In fact, today, the total cost of ownership for Ethernet is 55 times lower than with InfiniBand.
Mansour, so Ultra Ethernet is being developed particularly for this kind of high-speed, the highest speed connectivity and the latency issues in the systems that you were talking about. But are you talking about that? Because Ultra Ethernet initially is pretty targeted in terms of its use cases, right? So are you speaking broadly about Ethernet as it exists right now, or are you signaling towards Ultra Ethernet?
So I'm talking about Ethernet broadly, and Ultra Ethernet is yet another standardization effort on top of Ethernet. We saw RDMA back in the RDMA over Ethernet back in the day. Rocky, etc. So there is always going to be improvements to Ethernet, and that has been part of the journey with Ethernet. And yes, we are part of the Ultra Low Latency Ethernet Consortium. And we expect there will be some good innovations coming out of there, and I suspect Praful is going to talk a bit more about it in the sessions today. So just give you an example with Juniper of the breadth and the performance of these Ethernet solutions. With Juniper, we both have Broadcom-based solutions. We're partners with Broadcom, and we deliver some of these solutions to market. And then we have our custom solutions, a wide range. Just looking at Broadcom for a second here, just over the last 12 years, look at the kind of incredible improvements in performance. Back in 2010, we had 64 ports of 10 gigs, 640 gigs in one chip. At the time, it felt like an incredible amount. If you look at today, we have 64 ports of 800 gig, 51.2 terabit per second of performance in just one chip. I mean, this is kind of the level of performance you get with Ethernet. But you're not stuck just with that. You can, if you want deeper buffers, if you want more programmability, which you're going to need in some use cases, then you have solutions for that. And that's just in the context of Juniper. You have other vendors, plenty other vendors out there. And so hopefully I've convinced you that Ethernet is kind of like the right solution. And in fact, even NVIDIA in their earnings calls a couple of weeks ago admitted that Ethernet is going to be, even for them, a multi-billion-dollar market. And so this is a really important market for us to go after, and we're indeed very focused on it. And this is what analysts are saying. Deloro on the left, they're predicting that this backend network will be growing at 65% year to year. And you can see the impact on the total addressable market on the right here. This is 650 Group. You can see how it's turbo boosting the total market for Ethernet from $22 billion today to $32 billion in just a few years. And so, of course, with Juniper, we haven't stood idle. Since actually, I got in the role here back in September, we've really accelerated all of our efforts towards kind of delivering solutions for AI cluster. And remember that 51.2 terabit per second chip, we were the first to announce it, and that's what I was describing back in January in the blog. But now it's shipping and it's being deployed in some of the largest clusters on the planet today. And of course, that's just one switch amongst many switches. We have a whole portfolio, whether you have use cases that require that type of performance or different types of use cases, we have all of those switches for our customers. That's just one aspect of the strategy. The other aspect is operations, right? As I mentioned, you need to fine-tune these clusters. You need deep visibility into these clusters. And of course, we have Apstra, right? And Apstra is extremely valuable in the context of AI clusters for two reasons. One is that, as I mentioned, you can collect any telemetry you want and run any tests you want. If you care about visibility to understand exactly what's going on, you need that capability, and Apstra provides it uniquely. The second is that, as I mentioned, these systems are complex, and you talked about ultra-low Ethernet consortium, and there is lots of new features and knobs you have in these networks. And you want an ability to tune these networks to get optimal performance. And you may want to do this dynamically in real time. And in fact, one of the demos today is going to show you how you can use Apstra in order to tune these networks based on what you see. So essentially a closed loop system leveraging Apstra to fine-tune the network for optimal performance. So that is also something that we have uniquely and that we're delivering as part of our solution. And last but not least, and you're going to actually have the chance today to visit our lab here, we are becoming, as I mentioned, AI experts. And in that context, we've built a whole lab here for AI. We're learning every day in this lab. All of the folks you're going to see here, they've spent so much time in the lab, including myself. I love to visit and spend time in that lab. And we are learning with our customers. Our customers are spending a week at a time with us, tuning their networks, tuning their models in the lab. And we are sharing these learnings with our customers and packaging them in what we call validated designs. So we're making it our business to deliver end-to-end performance, not just think of the network as one component, but figuring out how to deliver these end-to-end solutions for our customers. And we're packaging them in these validated designs. If you have a large LLM, we know like this is the cluster you need. This is the cluster design you need. You have a smaller network, maybe you want to fine tune a model. That's a validated design. A self-driving network model, that's a validated design. Inference, a validated design. Think of them as blueprints for these different use cases. Turnkey validated designs. So that you don't have to choose between either I have to assemble it all myself because I'm choosing the components, or I get a turnkey solution. You can get a turnkey solution while getting all of the flexibility of being GPU agnostic or vendor agnostic. And so I'm going to leave you with this. This is a survey that Barclay did. It has been, it's been conducting this survey over many, many years. And in fact, it was Michael Dell that shared this on his Twitter feed. Many years ago, when you asked CIOs if they were thinking of repatriating their workloads, only 43% said that they were. If you ask this question today, 83% are saying they want to repatriate their workloads into the private cloud, into on-prem. And there are two reasons for this. One is with AI, data is becoming of primordial importance. And customers are a lot more hesitant to ship away this data in areas where they lose control of it. And it becomes super expensive if one day they want to think about bringing that data back. And so they are increasingly building private clusters for their AI, the AI workloads. That's number one. And number two, with solutions like we've described today, like Apstra, like AI for networking, it is much easier than ever before to manage and operate private clouds. And so actually one of the demos today will be about how you can manage a private cloud as simply as you would a public cloud. And so for those two reasons, we're seeing this massive interest with CIOs in building out their own private data centers. And so it's a really interesting time. It's an exciting time. We're seeing progress every day. We're now deployed in more than 70 countries, and we're seeing more and more opportunities every day in these very exciting times. And so that's